All right, so on to section 3. Just like with section 2, I've broken this up into 2 parts. We'll look at the graphing of this next type of conic section called a hyperbola, and then we'll look at the writing of the equations. And you'll notice a lot of similarities between the two. As far as the definition, if you remember, the definition of an ellipse was that any point on them, so with an ellipse, you had your 2 focal points, and any point on the graph, when you took the distance from those 2 focal points and added them together, you always got the same number. A hyperbola, the definition, so again, we'll have focal points, which would be somewhere around here, and if you, again, find the distance from any point on the hyperbola and those 2 focal points. With a hyperbola, if you subtract those, you get the same thing. So this point, if I found these distances and subtracted them, I'd get the same thing as I would if I found these distances and subtracted them. So that's a hyperbola versus an ellipse. And you'll notice obviously the graphs look a little different. But if you look at the equations, you'll notice that the equations look very similar. Specifically, there's only one main difference, and that is that it is subtraction instead of addition. So, like with ellipses, you'll notice that the A will tell you, with ellipses we called it the major axis because it was the longer of the 2 axes. With hyperbolas we call it the transverse axis because it's the axis that goes through the actual graph. So, like here, oops, sorry. Let me fix my screen, there we go. So like right through here, that would be considered the transverse axis because it's the one that cuts the graph and goes through the 2 graphs. And when the graph is considered horizontal, that the transverse axis is horizontal. And for that, you'll notice that the x is first. Unlike with ellipses where it always went x first and then y, because you're subtracting, the order that it is actually makes a difference. And so whichever one comes first is going to tell you your major axis. And in this case, the A doesn't have to be the bigger one like it did with ellipses, but it will always be the one that corresponds with the transverse axis. So it will always be listed first. So let's go ahead and get to graphing, and you'll notice again, just like we noticed some similarities in the actual equations, you'll notice some similarities in the graphing as well, up until the very end. Alright, so here is our equation. First we need to find the center, which in this case is at 3, -2. Now, the one thing I just want to kind of point out with hyperbolas that it's a little different than ellipses is when you're finding your center, you want to pay particularly close attention when the major axis is vertical, in other words, the y is first, because it's easy to switch around the x-coordinate and the y-coordinate of your center. Because the x-coordinate is always with your x, and the y-coordinate is always with your y. But if the y is written first, it can be easy to accidentally write that number first, even though that's still the y-coordinate, still should be written second. So just kind of pay close attention to that, and we'll see some examples where it's a vertical one, and so you'll pick, so we'll kind of mention that as we get to those. Alright, so I'm going to start 3, -2, put my center, and then the initial process of graphing hyperbola looks the same as graphing an ellipse. Okay, so I'm just going to pick a light color to use here because you'll kind of see why as I go through. So this first part of what we're going to graph isn't actually part of the graph. Hyperbolas have asymptotes. They have slant asymptotes. And so what we're going to do is we're going to draw in the slant asymptotes. Now, in order to find those, we start the same way we start with ellipses. So I look underneath my x's, and it's a 9, which is 3 squared. So I'm going to go to the left 3 and to the right 3. Then I look under the y's, which is 16, and that's 4 squared. So 1, 2, 3, 4. 1, 2, 3, 4. All right, now if this were an ellipse, we would draw the ellipse and be done. So at this point, it's going to be different. We're not going to draw our ellipse and we're not going to draw our hyperbola at the moment. Right now, we're going to use those dots that we created to make a box. And then using that box, we're going to draw in the diagonals of that box. These diagonals are those slant asymptotes. And notice how I don't just draw them in the box, I actually extend them out, because the actual graph of the hyperbola is going to be completely outside this box. Okay, so I did it with dotted lines. This is also why I kind of picked a lighter color. When you're graphing it, just draw it lightly with your pencil, because this part isn't actually part of the graph, but it guides our graph. All right, so now is where we actually get to graphing the hyperbola. Okay, so the next step, once you get that box and those diagonals, is to determine which axes are, or which direction is our transverse axis. So which variable is listed first? In this case, it's the x. So our transverse axis is horizontal. So what that means is your vertices are going to be this point here and this point here. And so then from here, so those are your two vertices. And then from here, you're going to go up, and I'm going to do that one a little better. So the graph just goes up, and then it just goes towards those asymptotes. And then as it gets closer to those asymptotes, it just starts to hug the asymptotes. And there's the graph. And that is a hyperbola. All right, now the directions don't say this, but I'm going to go ahead and do it just because, again, it'll help us when we get to the equation writing part. So just going to look quickly at those focal points. So c squared, if you noticed on the previous slide, to find your focal points, again, there's similarities to the ellipse, but it's not the same. This time the a squared plus the b squared gives you the c squared. So that's going to be 9 plus 16. So c squared is 25. C equals 5. So in this case, our focal points will be 5 units away from the center. And those are going to be on our transverse axis, which means in this case, since x is first, they're going to go horizontal. So from the center, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, and those are your focal points. Okay,